monitor, they engage the people involved in that work, and they support work in that area. The third one is the one that I spend a lot more time on now, which is in the warfighter performance area, and particularly in the health and survivability. So this is basically biomedical or biotechnology related applications coming out. And one example to focus on here is what's called the warfighter health and survivability objective. This is just one of them underneath. And this is biomedical. So first one is predictable. Improve the continuum of casualty care from points of injury, definitive care, and treatment facilities. We have basically reduced the battle, these programs in the Army and the Navy have reduced the lethality of battlefield injury markedly. In fact, some of the problems we see that we're dealing now with traumatic brain injury and other long-term consequences are because people are surviving injuries that used to kill them. And I can assure you that these other issues now, I was at a conference last week, a State of the Science conference in the Washington, D.C. area, looking at one of the issues for long-term health risks from repeated low-level blast exposure that you might get occupationally in the military and in other sectors. We just had one that I was participating in yesterday remotely, looking at preventing hearing loss and long-term consequences of this. So all of these issues are now bringing new medical issues to the forefront from the success and continued improvements in this area. The second one, reduce the incidence of noise-induced hearing loss and explore mitigation and remediation. This is a major problem in veterans. It's been recognized for more than a decade at the level of the Navy that one needs to look broadly at it, and I'll show you some of the program, how the program cuts across many disciplines in a moment, looking at that. Body armor, okay, health performance in undersea operations, that's a particular Navy issue. There are a lot of issues that take place in a submarine environment working in it, and the underwater health, undersea health program is one of their major thrusts, and also enhancing resilience when one faces physical and psychological stressors. So these are their main emphasis areas. And one of the problems in the military that's been recognized, that again will show the breadth of a program right down at the most basic management level, is the problem that noisy military operational environments give you a very high prevalence of hearing loss. After more than half the people who go out of the military after a full 20-year career, they're in noisy environments. They have much more significant hearing loss than individuals of the same age. They're exposed. There's a lot of just military environments are just plain simple noisy environments, noisier than industrial environments. And people don't like to wear their hearing protection. If you're told to wear earplugs in combat, you can't hear your buddy, you're going to wear those earplugs. Okay? These are the kind of problems that you face. So what they've taken to this is a classic military uses the systems approach for many things, and looking at the different components that are involved in there. So we would say the hearing loss is a function of two things that we might be able to manipulate or have some control over or understand. Number one is the environment. Can we do things about the noise or the equipment or other items in the environment? Second thing is the humans. Can we protect them better with personal protective equipment, or can we actually biologically protect them? Are there biological hardening mechanisms that can go on? Are there genetic predispositions so we can select people? A series of these kinds of issues, and these all come into the area of the Navy working on it. And this whole approach to preventing hearing loss has led to a program that focuses on four main pillars. Engineering controls. Can I make a quieter jet engine? Individual susceptibility, understanding it. Are there certain risk factors that predispose a person to that loss? Suppose I've had that day out there and I go in and I put in my earbuds and I start blasting music at night. Might there be some personal issues? There might be issues such as that. Alcohol, drug consumption. genetics that introduce it and enter into it? Are there medical interventions that I can make in these individuals at different times with testing and monitoring to rescue hearing, if you will, and improvements in personal protective equipment? And this slide was given to me by my colleague Kirk Yankaskis. This is taken right out of an internal report that he gave about 2 weeks ago to the directorate of the Office of Naval Research on the thrust of his program. And this just shows the active research going on in this area at this time. So for the noise reduction, they have acoustic engineers actually, and a whole team of people who've gone over all the operational model ships. They've built computer models of them, they've made detailed measurements, and they are actually changing the design and application of sound damping equipment inside those ships to lower the noise risk to personnel. So that area, that's engineering, materials science, acoustics, one area of development, and all of that is based upon the new material development they're supporting, looking at new nanomaterials and other materials. That's the basic research. That's the part that's leading to all of those Nobel type of contributions and basic science advances. The recognition that the technologies to solve these problems come out of pushing the boundaries of the science is something that's implicit, that's accepted as a base value in terms of the military systems, you can see from the way it's set up. Okay, shipboard noise path validation is actually a very interesting area. You can tell those of us who are part of these programs had to sit and listen to all these different areas. We learn a little bit about it. It turns out that just the kinds of plumbing or pipes and the way the conduits were set up for this in the ships were creating a health risk. Engineering modifications are taking care of that. And now a major issue is looking at jet noise reduction. The new Joint Strike Fighter kicks out, makes so much noise on the deck of a carrier that we cannot protect the person's hearing from it without substantially changing the way people work. The engines are so powerful, even custom fitted, the best fitted hearing protection, because of the reverberation, the properties of the acoustic properties of the head and of the body, will not protect you. So that's known, and before it's deployed, there are measures taking place to control that and to make that safe for the individuals exposed to them. And it includes different engineering modifications for jet noise reduction, and there is a lot of aeronautical engineering work, applied physics work that's going on and supported by these programs. And supported, by the way, for the program, they don't need that for changing for making the weapon more effective. They need that for protecting our forces. And that's the warfighter protection component of it is driving this whole area of research, which, by the way, as these more powerful engines get moved over into civilian aircraft and applications, it will enable us to build better jet engines, more efficient jet engines, less noisy jet engines for everyone's benefit, and that's recognized. And the basic research they're paying for, this shows you basic modeling research on jet engine design that's being supported with the goal of hopefully reducing the noise to prevent the health threat. There are new methods for assessing hearing and standard cell biology type, the biomedical work, the kinds of things that people like me do in the laboratory, which are being supported. And it's very basic biological research, either in vitro or in vivo, looking at how cells are injured, how they die, how interventions might work. And finally, there are a series of advances in protective personal equipment. And one of the things that's very interesting here is there's been an adoption of some of the laser scanning and three-dimensional manufacturing, three-dimensional printer manufacturing that's being used now, so that we can actually think about custom design of protective equipment that can fit and work better with built-in other kinds of engineering controls, maybe controls that can help you, that maybe make the person more resistant to hearing loss, that can extend safe human performance out into these areas. And the process, I can tell you that having gone through and helped Dr. Yankaskis, with review of this program a couple of times as one of his consultants on this, that helps with this building brains of everybody in the field. How else would a guy like me get to learn about jet engine design or some of the issues that go into it? Or be able to communicate with the engineers and see that there's certain areas and problem spaces that we do have in common. What they are really doing is what we're not doing as well at universities as maybe we used to in the old days. And that is getting cross-fertilization of academic work between people in different disciplines. They've really functioned quite well in building their team in terms of building an intellectual infrastructure to start solving these problems. We get together, we brainstorm for new approaches which come in as basic researchers' concepts and ideas, and it's intellectually stimulating. And what it's really driving when we say TRL1 approaches, what we're really saying is it's driving work leading to basic principles, leading to publications and transmission through basic disciplinary journals and basic disciplinary sources that are driving the field broadly for that particular goal. And so we can sort of summarize, from my experience, I've come to realize that the Department of Defense system really is a deliberate and managed knowledge acquisition strategy which produces useful deliverables down the line that protect and support their personnel. But what it really does, because of the vision and the way that they've set this up, it actually works like a tree. We in the research community are like the roots and the trunks coming out of it. We're laying down on a longer time frame basic information, basic knowledge, basic heuristics, developing our disciplines and developing broader disciplines that feed those later applications in the military and civilian world that I will say emerge like the branches and like the leaves on the branches. And so what I've sort of come to realize after a couple of decades of working with the military, and I want to thank Paul for giving me a chance to think this through like this, I've come to realize that what we've really been doing is engaging in a system that's actually I've been engaged in a system that's actually quite effective in building our scholarly infrastructure. It's certainly, retrospect in some of the areas that I do work in now and consult in now, I never would have known anything about them. Some of them didn't exist before getting involved there. And it's a very effective way of organizing us in the research community to do what we do best, push the boundaries of what we do best, and by the way, provide them with the building blocks that they need for pushing on into products to meet their very specific missions. Thank you.